Last time we started to talk about the new method to analyze the circuit, which was the mesh current method. And basically what we did was that we consider every loop in our circuit, then we assign a current and the direction, the current magnitude and the current direction in each of the loop, and then we start to write a Kirchhoff voltage law for every loop, and then that gives us a series of equations, and then we solve all these equations all together, and it gives us the current and eventually the voltage in all elements in the circuit. Now I want to go one step further and talk about a circuit. If what we have so far was the one that has the voltage source in it, so like a battery. Now I want to look at it, what if we have a current source in the system, what would happen. That so is the at this moment we want to use the mesh current method for the circuit that has the current sources. So what we are going to do is just the mesh current method for circuit with current source. This is what we want to do. So what happens if you have a current source? Well, let's first stop. Let's first start with a very simple example, and then we go to a little bit more complicated one. So for the first, assume we have a circuit like that. So have the current source that has a 2 amp current, and then it's going to be correct to the resistor here. Then we have the resistance here, and then one resistance on the top here, and then we have the voltage source for battery sitting here. There's a 10-volt battery, let's say, for voltage source, and then let's see. So it's going to be one the circuit we have. So it's going to be 15 ohm. Then we have the 10 ohm here, and we have 5 ohm. So assume we want to solve this problem with the mesh current method. So if you remember, when we want to do that, the very first step in the mesh current method is that go ahead and assign a current in each loop that we have. So here we have two loops here, the left and the right loop, and I said I'm gonna assign the I1 in the first loop and assume it's rotating clockwise, and the same for the second loop. I assume the magnitude of the current in the second loop is the I2, and also is rotating this one clockwise. So I have these two. The next step was that I should have go and start to write the as I said, the for each of the loop, write the KVL. So I first start to write the KVL for the right one, for the second loop here. So if I write the KVL at loop 2, so let me name them so we know what. So I assume this is going to be V1, this is going to be the voltage is going to be V2, the voltage in this one is V3, the voltage in this one is V4. just the magnitude of the voltage, whatever it is, we don't know, but we just, you know. So in the second one, if I start to rotate from here, so I start the loop from here, go all the way and comes back to that starting point, and add all the voltage together, I know that all the voltage should come 0. So the very first voltage I have here is the V4, then plus the V3, and then here, because I first hit the plus sign of the voltage, is going to be plus, and then 10 volt is the magnitude of that, it's going to be 0. So I know that and then I can replace each of these with the I value with the Ohm law, which was that we know the Ohm law was IR. So I'm gonna just replace every V with the IR. So the V4 here, if I look at the 4, this middle one, so I know the I2 is going upward here, and I1 going downward here. Does it rotate like that? So I goes up, I1 goes down, rotate like that, so I goes up. So I know that for that one, so I have the I2 minus I1, and the R is 10 ohm times 10 ohm is this equation. For the V3, I have the I2 times 5, which is the R is 5, and then plus 10 is equal to 0. So it's the first equation I'm gonna have, and I have it based on I1 and I2. Now let's look at if now let's go to the first loop and write the KVL at loop 1. So again, I know the sigma V should be 0, and then assume I start again from this corner here, go all the way and come back here. Now if I want to go, that's I know it's gonna be the V1 plus, then I have V2, then I have V4 is gonna be 0. So V1, what is voltage is this in current source, whatever voltage is this resistance, and whatever voltage is there. The problem here is that I have no way to know the magnitude of V1. I can replace the V2 and V4 with that, so I can say that, okay, V1 plus, and for the V2 I can say is I1 times 15, and for this one I can say I1 minus I2 times 10 is 0, but I have no way of knowing this V1. So I'm ending up having 2 equations and 3 unknown, I1, I2, and then the voltage in this one. Remember, the voltage in the current source is not 0. It has a voltage, but we cannot figure out how much it is based on this current configuration that we have. So I can write this equation for the loop 1. It gives me one additional equation, but it also gives me one additional unknown. So basically I cannot solve it. So in this format I have 2 equations, I have 3 unknowns. There's no way that I can do it. So basically this equation is just useless. I cannot use it. And this is the case for any time that we have the voltage source and we want to use the mesh current. So whenever we have the voltage source in the mesh current, we have to come up with another way of this equation we need. Here we have one equation here, so it's I call the equation 1, and I have 2 unknowns. So I need another equations, and I have to think of any other way to come up with another equation. This one is the very simple, is the very simple circuit, and for this another equation, what I can do is that I can look at the I1 and I look at here. So I know here is I1, so I know the current goes here is I1. So the I1 goes in this loop. I know the current here is I1, and I know this current source already forced the current to be 2 amp. So I know this current source make the current in this wire be 2 amp, and I know the current in this wire is also I1. So I can simply go ahead and say here, if I look at here, I can say I1 should be equal to 2 amp, because exactly this is what I have. That current source just push the 2 amp in that wire, and I know that wire current is I1, so they should be equal. So the I1 is 2 amp, so, and it's gonna be my second equation. So I use this equation along the first equation here, and then I can calculate. I already have the I1, so I can substitute I1 from here to here, and then find the I2 from there. The only point here is that this equation here is not going to be helpful. So when we have the current source in the mesh, we cannot write the KVL at that loop that contain the current source, because there's no way that we are going to know the voltage of the current source, and we have to figure out some other way for additional equation we need. Okay, let's look at another example, the circuit with the current source in it. Okay, so assume I have a resistance here connected to the resistance here, and then I have the current source here, and that current source has the 5 amp, and then it's going to be connected to battery, and then on the top have another resistance, like that, and then it's going to be 1 ohm here, 2 ohm, it's going to be 4 ohm, and we have 3 ohm here, and it's going to be 10 volt here. So assume this is what we have, and it's a circuit we have, and we want to analyze it for using the mesh current method. So if I go again, the very first step, I have to go and assign a current in each of the loops. So I have one loop here, I have one loop here, I have one loop at the top. I'm gonna just go ahead and assign, for example, in this one, assign the current in this loop, assume it's gonna be I1. In the second loop, assume it's gonna be I2, and in the top loop, assume it's gonna be I3. So assume I have these loops, and I want to write the equation for the mesh current equation for these loops. If I want to work with these ones, you can look at it and say, okay, which loop I can use. So here, if I go to the first loop, I'm gonna end up having the current source in that loop. The problem is that I don't know what's the voltage in that current source, so then I cannot write the equation. The same here, if I want to write the KVL for the second loop here, if I write it again, I have to I end up having the voltage of this current source in my equation, and because I don't know the voltage of the current source, I have no way of knowing that. Again, that equation is not gonna help me anyway. So I cannot use the first mesh or the second mesh, because they both have the current source in them. So I can use either of these to write the equation. So, but for the very top one, I can't do that. So I will start from that. So I'll just name the voltage in each of them. So assume it's going to be V1, it's going to be V2, this one is going to be V3, and this one is going to be V4. So these are the voltage they have, and whatever voltage that current source has, and we don't know, assume it's going to be V5, and there's no way that we know the V5, so we cannot write any equation that contains the V5 because we cannot find it anyway. So the only mesh I can write it right now is that at this very top loop here. So if I write the KVL at this loop 3, so it tells me the sigma V should comes as 0 if I add all the voltage. So if I start from this node here, go all the way up there, come back and go back to the very point at the start. So I have the V4, then I have the V3, then I have the V2 here. And if I add all of them together, it's going to come as 0. And then I use the Ohm law, as I said before, the V is IR. I use the Ohm law to replace each of these voltage with IR. So for the V4, it's going to be I3 times 3 ohm, then plus the V3. If I come here in the V3, what I have is, you can look at the I2 going this direction, and the I3 goes this direction. So if I rotate this way, it's going to be I3 minus I2. So the current in this is going to be I3 minus I2, or the inside current minus the outside current, times the resistance, times 4, then plus here for this one again. If I look at it in this one, the I3 goes this way, and then the I1 goes this way. Again, I'm rotating this direction, so I go this direction from here to here. So it's going to be I3 minus I1, because I3 is in direction of my rotation, I1 is against the direction I'm moving. So it's going to be I3 minus I1, or in simple one, just inside current minus outside current times the resistance, times 2 is 0. So this is the first equation I have. Now I have I1, I2, and I3, so I have 3 unknown and only one equation here. And I cannot use either of these two. So I have to think of another way of writing mesh current for this case. So one other way of doing, so I already used this mesh. I want to find a way to use these two meshes as well in my calculation. So this time, instead of I go along this loop or along this loop, I can go along, let me show you. I can go along this loop, so I can start from here and go through that, and they go through here, go through here, go through here, come here and go back here. So I can use this as my mesh. So these two, I can use 1 and 2 together, the outer part of 1 and 2 together as a mesh. So instead of going through one of them or the other one, I start from this line, go up there, then I stay at this wire and I stay at this wire, I come at this one and goes back. Still it's a closed loop. Because it's the closed loop, still I can use the KVL. So remember, for every closed loop you can use the KVL. So let me delete them. So this, so I will write the KVL at super mesh. So I call that super mesh, and basically it tells me that the sigma v should be 0 at that super mesh. And if I look at that super mesh again, let me show it one more time. So I start from here, go, 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 come back here. So this is going to be my super mesh. So this is the way I want to go. So if I look at that here, I start from this point at the very corner here, and I add all the voltage. If I start from here, so I have V1, then I have the V2, then here I have V3, then I have the battery, so I hit the plus sign first, so it's going to be plus, and then I have 10, and then I go back to where I start, so it's going to become 0. And then if I if I use the Ohm law and replace all the voltage with IR, so here if I come for the very first one, so it's going to be I1 times 1 ohm, plus for the V2 is going to be again I1, because this is the rotation I got, so I1 is in the direction of I rotate, so it's going to I1 minus I3, or inside minus outside, times 2, plus, then here again I have the, for this resistance I have I2 minus I3, because the I2 is in the direction I rotating, the I3 is against the rotation that I go, or in the simple, the inside current minus the outside current, so it's I2 minus I3 times 4, the resistance, and then plus 10 is 0, and then it's going to be the second one. So now we have two equations here, so it's the equation 1 and equation 2. Still we have 3 unknowns, so we need another equation. So we have I1, I2, and I3, but we have only 2 equations, and we already use all the meshes that we have. We use all 3 meshes here. So we have to find a way to find the third equation for our to somehow that we have the 3 equations to solve it. So to find the third equation, what we can do is that we have to somehow go ahead and see inside our circuit, see where we can find another equation. One way that we can look at it is that if I come and look at these 2 nodes, so from here to here, if I look at that node, that 2 nodes, and then I have, they have the current source, so of the 5 amp, and then goes up here. If I have this, if I look at that, also I have in this one, I know that if you look at the I1 is going like this. So I put it here. So this is the I1. If you look at the I2 go up there. So the difference between the current in this one is gonna be, I know that the current in this wire is, whatever it is, I know it's gonna be 5 amp. Assume, let me for example name it so for that, assume I call this E and call this F, so these 2 points. So I know that the current in goes from E toward F is 5 amp because of I have that current source in that. Now look at this I2 minus I1. Also I know that the I in the EF is difference of these two. It basically is the I2 minus I1 because the I2 is going from E to F and I1 is against that. So it's the difference of these two. So therefore I can go ahead and say that these two should be equal. So I2 minus I1 should come out as 5. And then there you have your third equation. So here then you can look at, so I have one equation here, I have the second equation here, and then I have the third equation here, and then I can use these three equations in order to solve them in order to find I1, I2, and I3.